Hey everyone, welcome to Trigonometry Introductions with SOHCAHTOA. In this one, we are going to be talking about sine, cosine, and tangent, and what they mean in terms of right triangles. Right triangles being when it has a right angle of 90 degrees. They often call it SOHCAHTOA. Sometimes I like to write it like this instead. SOHCAH and TOA. This is just showing that each of these three things is actually equal to a fraction. SOHCAHTOA. Sine is equal to the opposite side over hypotenuse. Cosine is equal to the adjacent over the hypotenuse, and tangent is equal to the opposite side over adjacent. So in the previous video, we talked about opposite, adjacent, and hypotenuse. And in this video, we are going to be doing, first of all, finding the third side, labeling as O, H, and A, and then writing out what sine, cosine, and tangent are going to be. And once again, it's going to be a fraction. So here we go. To find the third side, you have not this side. I'll just call it A. We have side B, and we have the hypotenuse C. So we would do A squared plus 3 squared equals 5 squared, which is A squared plus 9 equals 25. You subtract 9. You get 16. I know I'm going fast, but that part was already covered. So you get A equals 4. And now we have all three sides. It does say to do this from the perspective of angle A. So I'm just going to go ahead and say, well, we're talking about this angle. And when we're talking about that angle, I'm going to go ahead and label all three sides. So once again, I always do hypotenuse first. So this right here is the hypotenuse. If this is the angle, this will be the adjacent. So the adjacent is 3, hypotenuse is 5, and the opposite side is going to be 4. So the opposite is 4, adjacent is 3, and hypotenuse is 5. So if I want to know what the sine of the angle is, the sine is supposed to be opposite over hypotenuse. So the opposite is 4, and the hypotenuse is 5. Ta-da! Done. For cosine of theta, we use COS for cosine. Cosine is supposed to be A over H. So Ka is A over H. So A is 3 and H is 5. And finally, tangent, we just do TAN for short, of theta. I forgot to say that. Theta. That's how this is. THETA. Theta is that symbol right there. So tangent of theta equals opposite over adjacent. So the opposite side is 4 and the adjacent side is 3. And that is the answer. That makes some kind of sense. I'd pause and try B, otherwise you can just watch around. Once again, we do have to use Pythagorean theorem. A, B, and C, where C is the hypotenuse. So you have A squared plus B squared, which is 25, equals C squared, which is 64. So we get that. Once again, you can't really square root this one, so you're just going to leave it as the square root of 39. Like so. We are trying to find sine, cosine, and tangent of angle A right here. So I'll first label the hypotenuse, which we said was 8. From there, it looks like the opposite will be this. So the opposite is the square root of 39. And the adjacent is going to be 5. So sine, cosine, and tangent. Sine is what over what? Opposite over hypotenuse. So opposite is the square root of 39 over the hypotenuse, which is 8. Cosine is adjacent over hypotenuse, so 5 over 8. And tangent is opposite over adjacent, so opposite is the square root of 39 over adjacent, which is 5. And there you go. So that is sine, cosine, and tangent in right triangles. Other things to talk about now are these three new ones. Now, those ones you probably talked about in geometry. In Algebra 2, we get into secant, cosecant, and cotangent. And it might look like I wrote this wrong, but I swear I didn't. Reciprocals, sine and cosecant, are considered reciprocals. So like if the sine is 3 over 4, the cosecant would be 4 over 3. If I had secant and cosine, they are reciprocals. So if secant is root 3 over 5, cosine would be 5 over root 3. I know it seems a little backwards, like cosine and cosecant not going together, but I swear that's the way it is. Cosine and secant, sine and cosecant. Do keep in mind that in this one, there's a root in the bottom, so we would have to rationalize the denominator by multiplying the top and bottom by root 3. So you would get 5 root 3 over a regular 3 as your final answer. And finally, tangent and cotangent, a little more obvious than the other two. If you have 7 over 9, the other one would be 9 over 7. They are reciprocals of each other. So if you have one, you just flippy-floppy it upside down, and it turns into the other. So some other examples we'll be doing. If the sine of an angle is square root of 5 over 3, find all 6 trig functions. So sine, cosine, secant, cosecant, tangent, cotangent, all 6. The important thing to note here is that it's telling you that the sine is equal to this number. But remember, sine is not just a number, it is also this right here. Sine is opposite over hypotenuse. So this is implying that the square root of 5 is the opposite and 3 is the hypotenuse. And you can use that. The opposite side is the square root of 5, and the hypotenuse is 3. So once you have that, you can use Pythagorean theorem to find the third side and then do what we did before. So I'll do that kind of quick. A squared plus b squared, so the square root of 5 squared, equals c squared, so 3 squared. Root 5 squared is just a regular 5. And if you subtract 5, you get 4. And if you square root, the square root of 4 is 2. Cool. We already said root 5 was the opposite, and 3 was the hypotenuse. So dead giveaway, 2 here is going to be the adjacent. And from there we can do sine, cosine, tangent. Sine, they already gave it to us, square root of 5 over 3. Cosine, so ka is a over h, so 2 over 3. And toa for tangent. Toa, so it's going to be root 5 over 2. And that's the first 3. The other 3, remember, they are just reciprocals, so I can do cosecant is the reciprocal of sine, so that would be 3 over root 5. Cosine, flippy-floppy it, instead of 2 over 3 is 3 over 2. I don't know why I wrote cosine again. Cosine and secant are reciprocals. And then for cotangent, instead of root 5 over 2, it's 2 over root 5. And I'll quickly note that 2 of these, you do have the root in the bottom, so I am going to have to rationalize them. Excuse me. So 3 root 5 on top, and on the bottom is just a regular 5. And here, multiplied by root 5 again, so you get 2 root 5 over 5. And there you go. That's all 6. Bada bing, bada boom. Alright. This one, if you want, it's just like the other one. You can try it if you want. Cotangent is the reciprocal of tangent. Tangent is usually O over A, which means cotangent is going to be A over O. Reciprocals again. So this is cotangent, right? TOA, so opposites, A over O is cotangent. So this is the adjacent and this is the opposite. So I'll kind of do another mini triangle over here because Mr. Anderson loves drawing triangles. And I'll just do this angle. The adjacent is 5 and the opposite is 6. So we'll have to do a squared plus b squared equals c squared. So 5 squared plus 6 squared equals c squared, which is going to be 61. So the square root of 61 is the hypotenuse. And once again, I'll label these adjacent, opposite, hypotenuse. And now I'll go back and I'll use this triangle to find sine, cosine, tangent, secant, cosecant, cotangent. It's a lot of writing. Yeah. You just kind of have to suck it up and do it. Ugh. And cotangent. Yeah, so sine and cosecant are reciprocals, cosine and secant are reciprocals, etc. So sine is H, sine opposite over hypotenuse. So 6 over square root of 61. Cosine is adjacent. So adjacent over hypotenuse, 5 over root 61. And tangent is opposite over adjacent, so 6 over 5. Reciprocal of this is just going to be root 61 over 6. This will be root 61 over 5. And this will be 5 over 6. These ones you do have to rationalize the denominator. So when you multiply by root 61 on top and bottom, you get 6 root 61 over 61. And 5 root 61 over 61. Okay, one more and we're done. Whew. If you want, you can pause and take a break and get a sip of water or something. It's good for you. Next up, the last problem. Find the value of the trig function giving an ordered pair. And what I do is I just literally plot that point. It does not need to be exact at all. 8, negative 6, so I'll go 8, negative 6, and it's a point there-ish. You do not need to be specific. What you do need to know is that when you draw this triangle, you always start at the origin and go towards the point. So origin to the point. And then, depending on what quadrant you're in, you're always going to go straight up or straight down. You never go over. It's always straight up or straight down. Up or down. That's how you draw the triangle. But it's got to have the right angle on the x-axis, okay? Okay? On the x-axis. The right angle on the x-axis. Cha-ching, cha-ching, stars, stars, stars. You want to be a star, you listen to that star. If you draw a right angle on the y-axis, you drew it wrong. It's got to be a right angle on the x-axis. So go straight up or straight down to make your triangle in your practice problems. Now you can label two of the sides. If we got to this point 8, negative 6, then you know the distances. 8, negative 6. 8, negative 6. So this distance is 8, and this distance is negative 6. Just be careful when you use the Pythagorean theorem. Remember that when you square a negative, it turns positive. So negative 6 squared is a positive 36. 8 squared is a positive 64. And if you add those together, I believe you get 100. So 100 equals c squared, and you square root it, you get 10. Woohoo! And that's that part. You have all three sides now, where 10 is the hypotenuse. I forgot the other side. The angle is always at the origin. So there's another good note to yourself. The angle is always at the origin. So this would be the opposite, and this would be the adjacent. There you go. You'll learn later that cosine is considered the x value, and sine is considered the y value. So you could also do this as the adjacent, and that's the opposite. But that's much later. So from here, we're just going to do everything. The sine is opposite over hypotenuse, so negative 6 over 10. Cosine is ka, so 8 over 10. And tangent, toa, negative 6 over 8. And I just reduced those. Cosecant is the reciprocal, so 5 over negative 3. Secant is the reciprocal, so 5 over 4. And cotangent is the reciprocal, so 4 over negative 3. Shoo! Lots of work. Okay, I'm going to go ahead and do you a favor and stop talking. I hope this helped. And catch you guys later.